So now we're going to talk about some areas for improvement or just questions, considerations that we may or may not have the answer for. Again, I'm with my friend Nesbitt here, who is out in charge out here, and we're going to start with the borehole. So they have capped this off. This is going to be protective. One question I had is, when those rains come, will this area be flooded? And is there a risk of the borehole becoming contaminated because it fills up with water?
Probably not, because we've capped the borehole, and the end cap there is tight, so we don't expect that water will get in there. And also, we've just excavated this today, hoping that we will install the pump today. So if we install the pump today, then obviously this thing will be sealed off, and even if rainwater comes, it won't contaminate the borehole.
What are you using as a top plate?
We've got a 4mm steel plate. It's welded into like a box. So the box will be put in there. Then the outer space will be filled with concrete. Then we will seal it with a top welded.
So water cannot get into it?
No chance.
I see.
Chance. Sure.
Wow, that's really helpful. In other situations where maybe you weren't putting concrete on the actual wellbore itself, you have sanitary top plates that can be imported. I know that's probably not available locally, but it can provide a pressure tight seal, and so that no water can get in or out other than by the pump. And so that's another option. I was observing here and wanted to know your thoughts. I like the fact that these are factory screens right here. I was a little curious why a screen was run to surface like this. Like this is, we have. Was this always intended to be temporary? This thing here?
No. Most of the times the grouting is supposed to be done maybe the depth of 2 meters. When the borehole is done, and they put the sand packing, the gravel packing. After the gravel packing, then they have to put the grouting for 2 meters. So this is not 2 meters, it's just so because of the way we put the, how would I put the, like the secure we want to put there. So because of that, that's where we had to cut it off, so that we do our thing. But the grouting is supposed to be 2 meters deep, not just this from there. No, it's supposed to be 2 meters deep.
So and we don't have thorough drilling standards yet. So that's something that Charleston owes to the field. But I do know that we're going to be working on those. But just in terms of just like guidance and understanding and improvement, the one thing is we don't want to produce from the water table. So at what depth is the water table here?
We can't say the water table, the depth is the same everywhere. It depends from side to side. But I think from here, maybe the water table maybe is around 10 to 15 meters deep. Because there's a stream just yes. As you can see, there's a stream. So 10 meters, you'll find water there. But this place is very rocky, as you can see. There's a lot of rocks here. You just you only dig for maybe 1 meter, then you'll find a layer of rock. So
well, that's helpful. And so what other standards that I've seen, and again, I'm not saying there's a water mission standard, but you want to do the cement or the sanitary seal all the way to below the water table. So you want to get it into some basement rock, and so that could be 15 meters, maybe at a minimum.
Yes.
Sometimes it can be 45 meters deep,
Yes.
which is really deep, right?
Yeah, sure.
That's but so you can't do that with the grouting alone.
No.
You may have to use bentonite chips. And so again, this is not a standard, just guidance. This is commonly used in the U.S. is you drop bentonite chips down the annulus, and they're able to get deeper than the grout because you don't have to put a pipe down there, and then they will swell to twice their size in the hole over 24 hours. And so it provides a very tight seal, and water can't flow through it. So most of our turbidity comes from the water table in the unconsolidated, which means like this is unconsolidated.
Yeah.
The stuff that doesn't stick together in the hole, it's not rock. Those are where most of our well problems are coming from. And so if that is taken down to below the water table and into the basement rock or wherever the main aquifer starts, then you're not going to get the contamination from the surface. You should see a decrease in coliforms, decrease in nitrites, and then turbidity, which is, if there's high turbidity, that means we got to treat for that.
Yeah.
Because the chlorine, we would have to add more chlorine.
Yes. Yes.
And our tolerances are very low, below 1 NTUs on the turbidity. So that's one piece.
Okay.
Any questions on that? We can talk more after this.
Yeah, but okay, for what are you suggesting? I think because we cannot get them locally here.
Yeah.
That's why we just use the grouting.
Right.
Because
I don't even think they can get them in Nairobi. So we may. I'm not saying this or promising this, but this might be a consideration, an innovation perhaps, is to figure out how we can supply those. I mean, you drill 3 wells a year, or there's 3 projects a year. To be able to, I mean, these sacks are like $25 a piece. It's a lot of money, but it's not exorbitant, right? And so the other thing I wanted to talk about is that the screen is so high.
Yes.
And I've seen this in a lot of projects, not just in Malawi, but sometimes someone comes out with all the materials, and then like the emphasis from the driller often is on yield, not on water quality. There's very little water that will come from the water table compared to what's in the deep aquifers. And so there's no reason to put screens in the like deep reservoir aquifers.
Okay.
And so sometimes you'll see them just go plain casing, screen casing, plain casing, screen casing, all the way to the surface.
Or sometimes they say that where you're drilling and maybe you hit water at 4 meters, then at maybe 12 meters, at 18, so they just decide wherever we found water, then we have to put the screens. So because you've said that it's not good to put the screen on the water table, it's understood.
And that might be in how we might need to evaluate how we write the contracts as well, because the contracts are incentivizing or rewarding yield, which we want yield, but we also want quality. And so, like, I can show pretty quickly that not a lot of water is coming from the water table, only a lot of turbidity.
Yeah, you're right.
And so if we can focus on maybe producing from one aquifer and only putting the screens in a few different zones there, then we will have more integrity for them. Another consideration is that the PVC generally, and again, don't quote me on this, should only be run down to 50 meters. Because if it goes deeper, you face a lot of concerns about wellbore collapse. Because the ground, we're up here, but the pressure underneath the soil is much higher the deeper you go. And so the stresses on the pipe are not just uniform. It's not pressing in all at the same direction. It's like an oval. and I can draw this out, and so that will cause the casing to collapse.
So you're suggesting that maybe you've sunk a 100-meter borehole. So you should stop casing at 50 meters. From 50 to 100, you should not put any casing. Is it what you're suggesting?
Well, here's two different possibilities. It depends on the aquifer, and I haven't looked at this, but yeah, in some aquifers, if it's like metamorphic rock or igneous rock, you can do an open hole completion. That's what that's called. In many times that's actually recommended because the screens will just get in the way of the production. But you also have to have a seal to make sure that your gravel pack doesn't fall all the way to the bottom of the hole, right? Because that'll just go past. You don't want to run screens as much, especially towards the surface, because it will contaminate the well with all sorts of things. And so that you could either choose to do an open hole completion, or you could choose to do a steel casing completion, in which case, you know, you're protected. It depends on if you anticipate like collapsing on the well or not. If it's just bedrock, fractured bedrock, you're probably not going to see a collapse. But if it's unconsolidated or maybe gravelly, you might see a collapse. And it's not like the driller will be able to indicate from the cuttings whether it's gravel or if it's more of this. Yeah, so thank you. So this is what's called a shale trap, and I brought this with me from the US, but this can be put on the bottom of the casing. And then, so let's say that you have an 8-inch borehole. You put this around 4-inch casing, or in this case, you have 6-inch, right? Is this 6-inch? Or
yes.
Okay.
6, yeah.
Okay, so you put that around there, and then when you are dropping your gravel pack, or the bentonite, preferably, it will trap it in here and not fall all the way to the bottom. Yeah. So this is standard practice in the U.S. with open hole completions. You can also run things like K-packers, which will also brush against the side of the walls. And then
so if you want to use them here, then we will have to do a special order, because I don't expect them to be found locally.
No, you won't find them. We can't find them in Nairobi. So
Yeah.
So we'll have to, you know, that might be something that procurement can assist with. But look, you know, like you drill 3 wells a year, or 3 projects, and these are not, and comparatively, they're not very expensive, and they're easy to ship. There's nothing, you can put them in a box and ship a lot of them very quickly. So, so I know I'm talking really fast. There's a lot of stuff we're talking about, but the other aspect is you can you can use that bentonite, the expanding bentonite, to seal off certain aquifers and provide isolation. So you could run this at the end of your casing, and you would drop the bentonite in first, maybe like a meter or 2, and as long as it's not covering up a water bearing zone, and then you put gravel pack in, and then you put another seal on top of that, and so you're alternating on the way up between bentonite, a lot of gravel pack, bentonite, a lot of gravel pack, because unfortunately, if the gravel pack goes all the way to bottom and all the way to surface, then it provides a channel for contamination from the surface as well, because now it has a track to go all the way to the bottom. Hopefully over time that gets sealed off more, but the bentonite ensures that seal is made. All right, we talked a lot about well bores.
Yes.
Again, let's talk about the solar array. I praise what you guys did here. Do you mind holding this for me? So in painting, priming and painting ahead of time, the risk with using PVC, of course, is that it will degrade over time with the exposure to the sun. Are you guys planning on painting that as well, the conduit?
Or no.
So this is just a consideration. I'm going really fast. But you can consider also priming and painting that with oil-based paint, because oil-based will bond to the pipe, and it can extend the life of the conduit. And then we have on the cables. I'm not an electrical expert, but I do know Zach Sproul is, and he had talked about like maybe reducing some of the length of the cables and then re-crimping them. Do you guys have a crimper here?
Yeah.
You do have a crimper? Okay. And then it's great. On these foundations here, are these, how deep do these foundations go? This
I think it's 1.2 meters.
1.2 meters. Okay. And then do you put something a wider seal at the top? Like, do you kind of fill up the column, or is this the size of the hole all the way down?
Okay, it's like we just have to excavate 800 by 1500 hole and 1.2 meters deep. Yes.
Okay.
Sure.
Great.
So wherever there's like here, because there's a trench here, that's why we had to use the blocks.
Right.
Because there's a trench going there.
Yes.
Yeah.
One thing from just a hydrology concern for the future is this erosion right here. Like even you see that, and I don't know exactly.
I think it was because of that trench.
Yeah.
So when it rained, water was running through the trench, and when it reached here, because here it was buried, so then water had to dive it. And when it came here, because here is also a trench that is taking the.
I see. So it's just like finding the trenches.
Yes, it's the trench here. So that's why it's like settling.
Yeah.
Yeah.
Well, something you might be able to talk to Elijah, who's our new regional engineer, about is water. Water always has to find the lowest spot, right? So will the fencing be able to create a barrier so that future erosion doesn't happen along here? Just a consideration.
We will raise it up a bit so that maybe.
Okay.
Yeah. Because after we've done the fencing, we will have to level the ground.
Yeah.
And we will throw some quarterstone in here.
Okay.
Yes.
The solar panels are secured to the rack using these bolts. Are these bolts welded into place, or how are you securing the solar panels to the rack?
Yeah. Okay. After putting them there, after tightening them, then we have to lock them with a spot welding. Right?
Okay.
Yes.
Right. Is that
because we were afraid of them being stolen.
Is that pretty effective in allowing to prevent or reduce the stealing?
Like as our experience, we can't say much because this is our first to use this way.
Okay.
Mostly we use the rack. We have to insert them in and then we seal them off.
Yeah.
So when we were told to do it this way, we were so fearsome. We're like, really? Is this to me? I don't think they are safe.
Yeah.
You know, from other countries, people don't get carried away with this. But we don't have electricity from all these surrounding villages. There are no electricity. So once they see that they've got the solar panels here, they'll be tempted to come and take them away.
Yeah.
So when I was told that I should do them this way, I said, okay, my boss has told me to do it this way, I'll do it. But if I was asked to make a decision, I wouldn't do this. Because they want to be safe here.
Okay.
Yeah, they want to be safe.
Okay.
And,
Thank you for that feedback.
Well, for us to weld, you can't weld that much because you are afraid of
damaging the panels.
Yes.
Yeah.
So it was just a spot, like, so that maybe when somebody comes with a spanner, they won't be able to.
Yeah.
Yes.
It will slow them down.
Yes.
Yeah. Well, thank you for that feedback. That's helpful.
Sure.
I'm wondering about the water that comes through. Will that go into this
I was
square
talking.
tubing?
I was talking with Cornelius, and we agreed that we should make sure that we seal the tubes. Yes.
Okay.
So because it's work in progress, it's not yet done, but we agreed with Cornelius that we should make sure that water should not be getting in there.
Great.
Sure.
Wonderful. Sounds like you all are thinking ahead.
Yeah.
On this conduit here, how will that be secured long term to the square tubing column?
We will clamp it. We have
like this one.
Okay. Stainless steel clamps.
Yes.
Wonderful. That's the best. Yeah.
Sure.
Awesome. Do you find that people steal those ever?
Those?
Not
here. No. The things that we are afraid that they might be stolen here are the panels and the cables.
Yes.
But not the clips.
Okay.
Yeah.
Right. On these, what are you guys going to do on it with the pump house here with these open channel tubing?
Previously, we were putting a piece of timber, like a fascia board.
Yeah.
But recently, we were told that we should not be putting it.
Okay.
So we will just have to cut it and leave it like that, unless you advise otherwise.
I'm not advising in any way on this. I'm just asking the question.
But
what will happen
if you go to other projects,
yeah.
you'll find that we put the fascia boards around, so that nobody will see the hookings the way you're seeing them.
Yeah.
But for the 2-3 projects that we've done recently, we were advised not to put the fascia board.
Okay.
So because we do things as we are ordered.
Right. Right.
Yeah.
I understand, and sure. I'm not calling it into question. I am curious. One concern that comes to mind is that water will pool inside those channels and will rusting prematurely.
Yeah.
So this is how it will look once it's painted. It'll look like this.
Yes, according to what we were taught. But if they tell us that we should put the boards, then we will put them.
Okay.
Because it's an extra cost. At first, when we were ordering the iron sheets and the other things, we included the boards.
Yeah.
Yeah. So this time around, we did not order them.
Okay.
So if they say that we have to put them there, then we will have to order them.
Okay.
And if they are brought here, we are still here. We can do them.
I understand.
No problem with that.
Okay.
Yeah, sure.
All right. Thank you for that additional information.
Yeah. And what are you suggesting? Should we put them?
I'm not suggesting anything. I'm just suggesting that the question be asked and answered of how do we prevent those from rusting prematurely?
Yeah.
I mean, maybe part of the solution is using aluminum instead of steel.
Oh yeah.
But that's going to be much more expensive and might attract some attention.
Yeah. Maybe we should just drill holes maybe under, so that if water is there, should not stay there. Maybe like on the channels, just drill holes so that there's no pooling.
I really don't have a whole lot of comments here. This looks very, if you can hold your level up there, look, this looks very clean. You know, you have everything on a board here. Everything is plumb level and aligned. Will you be using a channel for the?
Yes, we have a trunk. We'll bring a trunk here. So then we'll use the small conduits. So they will run from here into the trunk.
Wonderful.
So after the trunk, then we'll have one trunk going down
Mm-hmm.
to there. So you won't be able to see the wires. They will be trunked.
That's wonderful.
Yes.
Okay, I know we can't take this apart right now, but if I were to look inside these combiner boxes, like or these fuse boxes, would I see any copper?
Copper like what?
Is there any exposed copper in the wiring?
No.
Yeah.
No.
So that's one rule of thumb right there is no copper.
Yeah.
And then you guys do the tug test.
Yes.
Do you know this?
Yes.
Yeah.
You put it, then you tight it, then you try to tug it to see if it's. Yes.
And then probably before commissioning, you'll want to go back and tug it again.
Okay.
Because it changes with heat, expansion and contraction.
Okay.
Yeah.
All right.
Awesome. Well, you guys have done a fantastic job here. Thank you for showing this to me.
Yes.
Yeah, keep up the excellent work.
Thank
So,
you.
thank you, Elizabeth.
Thank you.